Hello all, welcome to this session. In this session, I'm going to cover the next topic in Java in-depth course, that is data types. In the previous session, I covered variables. Now in this session, I'm going to cover the next topic, that is data types. So let's begin. What exactly are the data types? So earlier I covered this, right? In order to store the data in Java programs, we need variables, data types, operators, and literals. Okay. For that, I also gave an example. Int a is equal to 5. Okay. When I write something like this here, that is int a is equal to 5. When I write here, this, I told you already, int is a data type. Here I told you already that int is a data type. Whereas this a is a variable. I already covered what exactly is a variable in the previous session. You can refer to that if you have not watched the video or recording. Okay. A is a variable. Now, this equal symbol is an operator. Okay. It is one of the operators in Java. It's an operator. Then this value 5 or data 5 is generally technically called as a literal. These are the four elements, right? Okay. For a Java statement. Okay. This Java statement will be useful for or allowing us to store the data into the variable. Okay. With the help of this statement in Java, this is one of the example statements in Java, which will allow us to store the data in Java programming. Okay. In Java programming, if you want to store variables, is one of the example. This example statement has four entities. One is data type, another one is variable, other one is operator, other one is a literal. All good. The previous session I covered what exactly are variables. In depth I covered. Okay. In detailed manner I covered. Now, the next item that we need to understand is about this another element or component or entity, whatever you call, is nothing but the data type, guys. Okay. This is nothing but the data type. So using this data type, what we are doing in this statement is, okay, data types is the current topic. Okay. Data type will be used for declaring the variables. Okay. We declare the variables with the help of data types. Okay. We declare the variables with data types. There are several data types, guys. Okay. There are different data types we have in Java. There's no one data type. There are different data types in Java. Okay. Any of these data types can be used for declaring the variables. Some people call them as defining the variables. Okay. Declaring, defining. Okay. Whatever the way you want. Okay. Define a variable, declare the variable. Okay. Generally, people call declaring the variables. Okay. Using the data types, we can declare the variables. And we can declare the variable with any of the different type of data types that we have in Java. Okay. Here in example, int is one of the data types available in Java, using which we have declared this variable known as a. Okay. We have declared this particular variable a with one of the data types we have in Java known as int data type. What will happen if you declare a particular variable with one of the data types we have in Java? You see, if your requirement, okay, when you will declare this particular variable with a particular data type in Java, otherwise, a variable with particular data type when you assign, depending on the type of the data that you want to store into the variable, okay, depending on the type of data that you want to store into a variable, okay, depending on the type of the data we want to store into a variable, we declare the variable with appropriate data type. Okay. If you want to store this integer non-decimal values into a variable, then that particular variable should be declared with one of the data types known as int data type. Okay. If you want to store some other value, like instead of integer value, if you want to store some decimal value 5.5, instead of 5, you want to store 5.5, then you cannot declare the variable with int data type, because based on the type of the data that you want to store into the variable, that particular variable should be declared with appropriate data type. In case of 5, the variable is declared with int data type. In case of 5.5, the variable need to be declared with some other data type like, double, etc. Okay. There are different types of data types we have in Java. Based on the type of the data that you want to store into the variable, that particular variable should be declared with an appropriate data type. Okay. This word is all data types all about. So here, try to understand, guys, what exactly the data types are. we can define the variables. We can define or declare the variables. Any kind of terminology you can use, guys. We can declare the variables. We can define the variables with the different data types based on the type of the data to be stored into the variable. Based on the type of the data to be stored into the variable, we can define or declare the variables with appropriate data types. Okay. So then what are the different types of data types we have in Java? Then what are the different types of data types we have in Java? Different data types we have in Java. What are the different data types we have in Java? What are the different data types we have in Java? Okay, in Java, what are the different data types we have in Java? In Java, the data types can be categorized mainly at a high level into two types. One is primitive data types, other one is reference data types. Okay. Otherwise, I'll just draw this somewhere else. Okay. Different data types we have in Java. Okay. So here, data types, before I list down the different data types we have in Java, I need to categorize the data types into two categories for now. Okay. There are two types of data types we have in Java, guys. One of the type is primitive data types. Other category of data types we have is non-primitive or reference or object-oriented data types. Okay, reference means another word for object, guys. Reference or okay data types. Primitive data types, reference data types. Reference means object. Primitive means non-object. Primitive means non-object oriented data types. Reference means object oriented. But do you know what is object oriented? What is non-object oriented? At this point of time, you don't know. In the upcoming sessions, I'll cover what is an object and what is object oriented programming and all those stuff. But till that time, right, I may be using the word known as object oriented programming that you need to understand at a high level. Okay. So here is the thing. Data types in Java can be categorized into two types. One is primitive data types, other one are the reference data types. Okay. So in this session, I'm going to mainly focus on the primitive data types. In this session, though the topic name is data types, but I'm focusing, since we are at the beginning level, I'm not going to focus on the reference data types in this session. In this session, even though the topic is data types, one of the category type of the data types, that is primitive data types only I'm going to cover in this session. Why? Why not the reference data types? Reference data types I'll explain once I complete the object-oriented concepts of Java. Okay. In the upcoming sessions, I'm going to explain the OOPS concepts. OOPS means object-oriented programming. OOPS means object-oriented programming concepts of Java. I'm going to cover in the upcoming sessions, guys. Once I complete the object-oriented programming sessions of Java, then you will understand what are the different type of data types that exist in Java programming, that is reference data types. Okay. Reference means object, guys. Another name for reference is object. Okay. The data types which are object oriented types. Okay. Primitive data types means basic data types which are non-object oriented type. Okay. To get started, we can start with primitive data types which are non-object oriented. Once the object oriented concepts are completed, once I explain once you understand the object oriented concepts, then I'll explain the reference data types for you. Okay. Till then you wait. Okay. In the upcoming session, somewhere reference data types will be covered for you. Don't worry. So let's begin with the first category of the data types we have in Java, that is primitive data types, guys. What are primitive data types? Okay. What are primitive data types? As I told you, primitive data types at a high level are, okay, for now you understand, okay? Whether you know object-oriented concepts or not, try to understand. Primitive data types are non-object oriented. Okay, for at this point of time, you have to understand like this. Okay, primitive data types are non-object oriented data types we have in Java, whereas reference data types are object oriented object-oriented data types. Reference data types are object-oriented data type, whereas primitive data types are non-object-oriented data types. So you would have heard before you start learning this Java programming, anyone, okay, generally someone want to start with Java programming, anyone would have heard this particular line, that is Java is a object, okay, Java is an object-oriented programming language, right? You would have heard about this particular statement that Java is an object-oriented programming language. Okay, Java is an object-oriented programming language. But there is a twist. You are saying that Java is an object-oriented programming language. In such kind of programming language like Java, which is an object-oriented, which is called as object-oriented, there is one category of data types which are non-object-oriented. You see, you are saying Java is an object-oriented programming language. But there is one category of data types which are called as primitive data types, which are non-object oriented data types. That means this primitive data type proves that Java is not a 100% object. It is an object-oriented programming language. Without any doubt, Java is an object-oriented programming language because OOPS concepts will be there in Java and all that I'll be covering later. But Java is not a 100% object-oriented. Java is not 100% object-oriented programming language. What does it mean? You see, not complete. Okay, entire Java is not object oriented. There are some portions of Java like primitive data types. Okay, there is one portion of okay, there is something in Java which is not object. Most of the Java is object oriented, but there is something in Java which is not object oriented type, that is primitive data types, guys. Okay, since because of the primitive data types in Java, Java cannot be stated as 100% object oriented. If you go to other programming languages like Python and all those stuff, right, they're 100% object-oriented programming languages. But coming to Java, Java is not 100%. Okay, Java is not 100% object-oriented programming language, though it is called as object-oriented programming language, but Java is not a 100% object-oriented programming language. It's not a, okay, Java is not a 100% object-oriented programming language. Because of the, what is the reason why Java is not a 100% object-oriented programming language? The reason is primitive data types. We have some concepts known as primitive data types in Java, which are not object-oriented types. Okay, primitive data types. Reason is primitive data types is a reason why Java is not a 100% object-oriented programming language. Got it right? Clear? Okay. So Java is object-oriented programming language, but not 100% object-oriented, guys. Reason is because of this primitive data types. Okay. You see, why Java is still using primitive data types? Why Java is still using primitive data types? You see, for basic operations, okay, for basic operations, okay, for basic operations, if you use object oriented data types, okay, for basic operations, if you use object oriented data types, then okay, the memory and performance, okay, more memory and performance will be utilized. Okay, then more memory and high performance are required. Okay, more memory and performance are required otherwise. Okay, for basic operations also, for basic things, if you are using advanced things or object oriented things otherwise. Okay, for basic kind of operations you are going to do in programming, if you are going to use object oriented data types, it is possible, guys. Okay, we can ignore the primitive data types and directly go with object oriented data types and perform all the basic operations as object oriented also. But the problem with that is, because you are using object-oriented data types instead of the primitive data types for basic operations, more memory will be consumed and performance, okay? Performance will, will degrade. The programming performance will degrade. The program will run a bit slower when compared to the primitive data types. Okay, if you are using primitive data types, the speed of the programs, Java programs, will be faster when compared to the object-oriented data types. If there is a possibility of using primitive data types for performing the basic operations, okay, at least most of the things will be basic only, right? Somewhere advanced will be there. For basic operations also, if you use this kind of object-oriented data types, for every basic operation, more memory will be consumed and performance will slow down. The program performance will slow down. Okay. Because of that reason, Java wanted to have this primitive data types along with the reference data types. Okay. Java wanted to have this primitive data types along with the reference data types. Java want to have the primitive data types along with the reference data types. Okay. So that memory can be saved and performance can be improved. Okay. The speeder execution of the programs will be possible. So why not? Why not was the situation? Okay. why not we can use primitive data types is something Java thought about. Okay, well, other programming language felt that okay, this is a very simple thing. Why to confuse the people? Let's directly use object-oriented thing. But Java still, okay, Java is still stick to the thing like primitive data types, even though it compromises that it's not 100% object-oriented programming language. Most of it is a object-oriented programming language, but not 100%. And still it is using non-object-oriented primitive data types. The reason behind that is for basic operations, memory can be saved, speed of the programs can be improved, that is, performance can be improved. For that reason, nowadays also where the computer machines and server machines or whatever you call the memory we are using the computer machines or speed of the CPUs we are using in computer machines are advanced. But still, Java felt that let's keep it like that. What is the use? Okay, it's a benefit only, right? Why to you know unnecessarily waste our memory, unnecessarily slow down the process. That's what Java thought about, and still has stick to these primitive data types which are non-object oriented non-object oriented types. Okay, fine. Hope you got it right. For fast means performance, for good performance and less memory consumption, Java is still sticking to using the primitive data types in the programming. Okay, so Java insists you to use these primitive data types for performing the basic. Okay, when you are performing the operations with the basic types of data, or basic or most of the basic operations will be done with the help of primitive data types. So most of the areas speed will be increased and improved, and performance will be good and less memory consumption will happen. So Java want to have this as a good feature. Okay, why we have to waste the memory? Why we have to intentionally make our programs slower? Is what Java is thinking about. Okay, fine. For storing basic types of data, most of the times when you write the programs, right, basic operations will be done. Most of the basic operations with the help of basic data types will be done. And if you are using the primitive data types for the basic operations using the basic data types and all, that is primitive data types, which are non-object oriented types, okay, the speed of the program will improve, and also the performance, performance means speed only, right? And also memory consumption will be less. I'll be explaining how primitive data types will be, consuming less memory and will be speed and all. Okay. I'll be writing that here in the pending topics. How primitive data types consume less memory. Okay. After I explain the memory management and all in Java, right, you'll understand this, and less memory and support. Okay. Better speed. Okay. Speed means performance. That is performance. That is performance of the programs. Performance. Okay. Fine. So that topic I'll be covering in upcoming sessions, guys. I don't want to dig deep right now. Okay. Whatever I'm covering is already good. The next category of the data types we have in Java are the reference, okay, reference data types, guys. Okay. We have reference data types. Okay. Which are object oriented data types, guys. Okay. These reference data types I'll be explaining, okay, in the upcoming sessions. Okay. Reference data types I'll be explaining in the upcoming sessions. Okay. Somewhere here I have noted down, Okay, so I'll be covering about the reference data types. Okay, where exactly it is. Any statement I have written? No. Different reference data types we have in Java. I'll be covering this topic in the upcoming sessions. Okay, at this point of time, we'll be focusing completely on the primitive data types. Okay, only reference data types, which are object-oriented types, will be explained after I cover the object-oriented concepts of Java. Then you'll understand what exactly the objects are and object-oriented concepts are. Then understanding what are the different reference data types. When the appropriate time comes, I'll cover this for you guys. Okay, so let's wait for that particular time to come. Comfortably, we are going to learn the reference data type in the upcoming sessions. Yeah. So one of the example I have used in the previous sessions while I was explaining about the variables or this particular thing where, storing the data into the variables is like, this is a statement, right? This is a statement we have written int a is equal to 5. Here int is a data type we mentioned, right? Int is a data type we mentioned. All good. So now you need to understand about the naming convention of the variables. I forgot to take this particular topic in this previous session, guys. So never the late. I thought like though this particular topic, naming convention of the variables belong to the variables topic, but since I have missed it in the variables topic, I thought of covering this, okay, before I explain data types in depth, in to some extent in this session, right? I thought of explaining about the naming convention of variables because I don't want to make it late or delay anymore, okay? So here the naming convention of the variables, okay? The naming convention of the project is in upper camel case. The naming convention of the Java files is in upper camel case. The naming convention of the classes is in upper camel case, right? What about the naming convention of the variables? The naming convention of the variables is in something known as lower camel case. Lower camel case. Okay. For example, I'll write minimum. Okay. Minimum value is equal to 10, or minimum age is equal to 10, like this. Okay. Age is equal to 10. And maximum age or maximum allowed age is equal to 45. Like this, I want to write. So here, whenever you are creating a variable, here A was a variable name. Since I have written in a very single character, I have written, right? So you didn't understand what is the naming convention of this particular variable because there is only one character here. But when you see the examples of the minimum age and maximum allowed age here two words are there. The first word's first letter is also in lowercase, but upper camel case means all the three words first letter is in uppercase. But in coming to the variable names, here lower camel case. This project name is upper camel case. All the words first letter will be in uppercase. Whereas in variables, okay, not all the words first letter will not be in uppercase, guys. First word will be completely lowercase, and second word onwards, first letter will be in uppercase. This is called as a lower camel case. Okay, let me show in the image. Lower camel case. When I search for this, you'll get these images and all. You see, this is called as a lower camel case, guys. Okay. This is called as a lower camel case. When multiple words are there, from second word onwards, this bump will start. Okay. First word, you see, complete lower case is there. Unlike the upper camel case. In upper camel case, what will be there? Upper camel case will be like this. Every word's first letter, even the first word also, first letter will be in upper case, second word's first letter. But in lower camel case, this is what is the naming convention of the variables in this is what is the naming convention of the variables in Java case. Okay, you need to understand about the lower camel case. This is how the lower camel case will look like. This is what is a lower camel case will look like. I'll just paste that. Lower camel case will look something like this. Okay, like this it will be there. This lower camel case. Fine, great. Then the time has come for us to dig deep into the primitive data types. Okay, I have categorized the data types into two categories. One is primitive data types, which are non-object oriented types, whereas referent data types, which are object oriented types. Okay, object oriented data types. Okay, which I'll be covering in the upcoming sessions. Okay, reference data types will be explained later after explaining object oriented concepts of Java. I will be explaining about this reference data types. Okay, done. After explaining object oriented concepts of Java, I'll be explaining about this reference data types here. Okay. Okay. Done. Let's move on. Okay. Different primitive data types we have in Java. Since I mentioned that I will be covering only the data types which are primitive data types, which are non-object oriented data types in Java. Okay. So let's move on and understand what are the different primitive data types we have in Java. What are the different primitive data types we have in Java? There are 8 primitive data types. Okay. There are 8 primitive data types. There are total 8 primitive data types we have in Java. What are they? First one is byte. Second one is short. Third one is int. Fourth one is long. Fifth one is float. Sixth one is double. Seventh one is char. Last one is boolean. These are the total 8 primitive data types we have in Java, guys. What are the total 8 primitive data types we have in Java? Byte short, int long, float double, char boolean. Okay. These are the total primitive data types, okay, we have in Java, guys. Okay, these are the total primitive data types we have in Java. Okay, so here is the diagram, right? Okay, fine. These are the total primitive data types we have in Java, guys. Okay, so fine, great. Let me close this. Okay, fine. So I'll be covering each and every primitive data type for you. These are non-object oriented data types. Okay? All the primitive data types are non-object oriented for handling the basic operations with the basic data handling and all, right. Non-object or non-reference data types are non-object. Okay, object oriented. These are non-object oriented data types we have in Java. Okay. First one is what? Byte. Okay. So what are the different non primitive data types or non-object oriented data types we have in Java, guys? First one is nothing but byte. Then we have short. Then we have int. Then long, float, double, char, boolean. These are the total 8 primitive data types we have in Java, guys. Okay. First one is byte, guys. Okay. Let's look into the byte primitive data type we have in Java. Okay. I'll just save this and create a new class. Write a new class here. I'll just name this class as data types demo. Otherwise, primitive data types. Okay. Especially we'll write primitive data types demo. Okay. Primitive data types demo. Click on, select this main method, click on finish. Here, I'll remove the comment and here I'll write down a sample statement. I'll create a variable, guys. Let's say the variable name is A. I want to declare this variable. Okay. Based on the type of the data that I want to store into the variable, I want to declare the variable as byte data type is equal to. So based on the type of the data that I want to, store into the variable, I have to declare that variable with a particular data type, guys. Okay. A variable which is declared with byte data type should be assigned with which type of data can be stored into this variable? Integer data. First of all, the type of the data that you can store into the variable is integer data. What if I want to store 9 into this? Put a semicolon here to end the Java statement. Okay. Output. You see, this is fine, right? I'm storing 9 integer number 9 into the non-decimal, okay, non-decimal integer value or numerical value I'm going to store into the variable. For such kind of values, if I want to store into the variables, I can declare the variable with byte data type. Okay, I can declare the variable with byte data type. What if I make it 99? Still I can store this numerical non-decimal data type data. If I want to store this into the variable, if instead of 9, if I am putting 99 and also I can store. What if I add one more 9? If I want to store triple 9, here is the problem. Here is the problem, guys. Okay. That means this much big number, even though it is a numerical number, even though it's not non-decimal number also, this big number cannot be stored into the variable because you are declaring the variable with byte data type. If you are declaring a variable with byte data type, the byte data type, okay, when declaring this variable will allow you to store some number which byte data type can accept. Okay. So here some restrictions are provided by declaring this variable with byte data type. Byte data type is providing some restrictions to the variable and it's insisting it to not accept some kind of data which is not supported by this data type. Okay. Based on the type of the data that you want to store into the variable need to be declared with appropriate data type. But here 999 cannot be stored into the variable because variable A is declared with byte data type. I can store 9, I can store double 9, but when I store 999, it's problem. Okay. Up to 99, okay. Let's understand why the byte data type is not allowing the variable to store 999 here, why it's giving the error. So this is another compiler error we are getting, guys. Okay. You see, in one of the previous sessions, I told you, right, there are hundreds of examples for compiler errors, but I was giving only 3. But the time has come for us to experience other compiler errors also. Before running the code itself, Java compiler is automatically, in the Eclipse side, is automatically compiling this code and giving me a compiler error. The compiler error is stating that type mismatch cannot convert from int to byte, it is saying. Okay. This is integer literal, guys. Okay. This is called as literal, right? This is called as integer literal cannot be stored into the variable which is declared with byte data type because it will not support byte data type will not support this kind of, okay. Byte data type declared variables cannot store this kind of values. Okay. Because these are integer values cannot be converted to byte this kind of, okay. What's the problem here? Why 999 is not allowed here? Let's try to understand, guys. Okay. You see, there is something known as range, guys. Okay, there is something known as range. A range of values only can be accepted into the byte. So here, You see, what are the range of values that can be accepted by the variables which are declared or defined with byte data type? Only the values from minus 128 to 127 can be accepted by the variable which are declared with byte data type. Okay. What if here I say 127? I can store. Okay. 127 I can store. What about 128? Error is coming. One number bigger than 127 will not be accepted because here you can clearly say the maximum positive number is 127. Behind 127, you cannot store into the variable declared with byte data type. Okay, byte data type cannot accept the value behind 128. Then compiler error is going to come. Up to 127 only possible. If you write 126 also not a problem. 127 also not. Last number is 127 positive numbers. If I write 128, there is going to be a problem, guys. Okay. In case of 128, I'm going to face a problem. This is what is the problem. Up to 127 only. And if I put a negative number, minus 127, minus 128 also will be accepted, guys. Okay. Lowest number will be minus 128. Lowest negative number will be minus 128. If I give it minus 129, I'll get an error. It cannot go below the 128, guys. Okay. Up to minus 128 only or plus 127 only. Okay. Or plus 127 only. This is the range of data that you can store into the variable declared with byte data type, that is minus 128 to 127. How can we know that this particular variable declared with byte data type can store the values from minus 128 to 127? How this can be decided? You see, every data type will have a size, guys. Okay. The computer memory, when you store some data, create a variable and declare that with byte data type, some memory will be reserved, right? This much amount of memory will be reserved for that particular variable to store the data, right? That memory size will be only 1 byte. Okay. The reason behind that is, okay, byte data type size will be how much? Only 1 byte. It's only 1 byte, guys. Okay. 1 byte in computer language is equal to, okay, in computer, we measure the memory of the computer in bytes, right? 1 byte is equal to 8 bits. Okay. Okay. The size of the byte data type in Java. Okay. This may be asked in the interviews, guys. You should be aware of this. The size of the byte data type is 1 byte. Okay. 1 byte, as the name speaks, byte data type, the size also is 1 byte only. Okay. 1 byte is equal to 8 bits. 8 bits means to represent a number, Java will use this kind of thing. 10110011. Okay. A particular number, let's say 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. Totally 8 bits are there. Okay. Only machine will understand only zeros and ones, right? Here 8 bits means combination of 8 places where each and every place may have either 0 or 1. Okay. That's what is a computer language is all about, how to measure the size and all. Okay. Byte data type will have 1 byte, which is equal to 8 bits. Okay. So there is a formula to calculate based on these 8 bits and all. Okay. There is a formula to calculate how much amount of data can be stored into the variable declared with that particular data type. Okay. 2 power. Okay. 2 power. Here you write down the formula, right? Minus 2 power. Here how many bits are there? 8 bits, right? 8 minus 1. 2 plus 2 power. 8 minus 1. Okay. 2 power 8 minus 1. And overall, this should be negated by minus 1. Why? Should minus 1 from this final value. Okay. Because there is something like 0 in between. 0 also will be counted. In the positive numbers, 0 also will be counted. That's why the negative numbers, an extra number like minus 128 will be there. In the positive, only 1 till 127 will come because of this minus 1 rule. Okay. Minus 1. Because of that, only up to 127 it will come for this byte data type. Because there is something known as, in between the minus and plus, there is something known as 0. 0 should either fall into the negative values or positive. If you are considering that, since we are considering that 0 as a positive thing, 0 and remaining numbers, that is 0 and 127 numbers, that is total 128. This side also negative numbers will be 128, positive numbers will be 128. Because of the 0, positive numbers will have one number less. That's why minus 1 we are doing. So this is the formula, guys. Okay. So how to calculate this formula? Minus 2 power. Here 8 minus 8 bits, because of the one byte is 1 byte data type is 1 byte and 8 bits. So 8 minus 1 is 7. 2 plus 2 power plus 2 power 7. And finally the resultant minus 1. Okay. 2 power 7 minus 1. 2 power 7. Okay. Till here. After this result is done, then minus 1. Okay. 2 power 7 minus 1. Okay. Simple. Now 2 power 7 means how much? First of all, 2 power 7 means how much? 2 into 2 into 2 into 2 into 2 into 2 into 2. 7 times you have to multiply the same 2. Okay. So that means minus 2 into 2 into 2 into 2 into 2 into 2 into 2. 1, 2, 3, 4, 5, 6, 7. Okay. 2 plus 2 into 2 into 2 into 2 into 2 into 2 into 2. Okay. 7 times plus thing also. Okay. And then result is minus 1 again. Okay. This positive number minus 1. Why are you putting minus 1? Because of the 0. In between this number, there is 0 because that 0 should come into the positive side. So minus 1 I have to say. So when I write like this, 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, 32 to the 64, 64 to the 128. So minus 128 this side, minus 128. 2, here also 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, 32 to the 64, 64 to the plus 128, plus 128. But since there is 0 in between, we are calculating minus 1 here. So plus 128 minus 1, how much it will become? Plus 127 it will become. The range is from minus 128 to minus 128 to plus 127 because of the 0 in between. Okay. So this is how we need to calculate the range of the data types in Java, guys. Based on the size of the data types, we can get the range. So since the byte data type has a size 1 byte, which is equal to 8 bits, and there's a formula like to calculate this, there is a formula, right? Minus 2 power 8 minus 1, that is 8 bits. Okay. 2 plus 2 power 8 minus 1, and overall the result minus 1. This is the formula again. Okay. Here 8 bits. Okay. 8 stands for bits. 8 stands for 8 bits. Okay. Like that you have to calculate, and the result will come as minus 128 to plus 127. And the example is like this we can use. Okay. Already I gave the example. Okay. It will accept the values from, it will accept the 0 also. You say 0 is also a positive number. Okay. Minus 128 to 0 can be accepted, or plus 127 till 127 is the range. Find a bigger number than 127. If you try to give, right, you are going to get an error, guys. Okay. 128 cannot be stored into the variable with byte data type. What type of error is coming? Mismatch, cannot convert from into to byte. Okay. This integer value is not in the range of byte, something like that it is saying. So up to 127 only I can cover. Okay. I can print it out also. System.out.println, system.out.println, syso, control space u, right? And print a, the value of a will be printed in the output console without any problem. That is 127 will be printed. So this is nothing but the byte data type we have in Java, guys. Okay. This is nothing but the byte data type we have in Java. The next one is after byte data type, the next one is short data type. What is the difference between byte and short? Short and byte are mostly same. Okay. Numerical non-decimal value can be stored into the variables with the help of short. Numerical non-decimal values. Numerical non-decimal values also can be stored into the variable declared with a short data type. But the problem here is, okay, but the thing here is short is double the size of byte. What is the size of the byte? 1 byte. What is the size of the short? Double the size. That is 2 bytes. Okay. Short is 2 bytes, whereas byte is 1 byte. Short is 2 bytes. Okay. That's what you need to understand. Here, if I write down short data type, okay, short data type, the size of the short data type is 2 bytes. That is equal to 1 byte is equal to 8 bits, right? 2 bytes means 2 8s are 16. 2 into 8, that is 16 bits. 16 bits. If you get 16 bits for 2 bytes, if you are the size is 16 bits, you can imagine, right? 1011001112. This here only 8 digits are there, but here 16 will come. So combinations of the data also that you can communicate to the machine. Also, this language can be understood by your machine, computer machine, in zeros and ones. Okay. So more the digits are there, which are storing ones and zero, the more combination of data can be stored into the variable, right? So that's what is the thing. If you really understand, okay. Here the formula, you know, right? Minus 2 power 16 minus 1, that is minus 2 power 15. 2 plus 2 power 15 minus 1. Okay. So 2 power 15 is how much? 2 power 15 is how much? Okay. So don't worry about that, guys. You can do the mathematical calculations later. It will come around minus 32,768 to 32,767. The same formula you can use here, guys. Okay. But here minus 2 power 16 minus 1, that is equal to 16 bits, right? 16 bits. It's 16 bits. So this kind of range will come. So short will, you can try it by yourself, guys. Okay. Minus 32768. You can also type something kind of tools like ChatGPT, etc. 2 power, how much is the value? 2 power 15 is how much? Okay. If you write 2 power 15, you will get the value. 32,768 is the value, guys. 32,768 minus 32,768 to plus 32. Okay. Till here minus 1 will be there in the formula, right? That's why 0 will be included. So 32767 only it came. Okay. Yeah. Let's try and see whether that is being there or not. Short B is equal to, if I write 9 here, not a problem. If I write double nine, not a problem. If I write triple nine, not a problem. If I write 4 nines, not a problem. If I write 5 nines, then there is a problem because this value is more than this number, that is 32,767. This is all nines. Okay. If you're trying to store a value which is greater than 32767 into the variable declared with short data type, it will not accept. Up to 4 nines it accepted, right? Even 32767 also will be accepted. The moment you increase the value of last number by 8 also, it will not accept. Okay. It's out of range for it. Okay. Cannot convert from into to short again. This amount, this much bigger number can be stored into the variable with declared with short data type. Okay, up to like this only you can do it. Okay. Yeah, try to print the value of b, guys. Okay, hope you understanding the concept because I already covered everything about the byte data type. So same thing will be repeated for the concepts in the form of for the short data type also. 32767 is a final thing. If you want to store a bigger number into this variable, then that particular variable should be declared with a different data type, which allows you to store a bigger number in Java programming. Okay. So the next data type we have in Java is okay, here byte keyword we have used. This is also predefined keywords we have in Java, guys. Byte is also a predefined keyword we have in Java. Okay. Like class is a predefined keyword in Java. Okay. Byte is also a predefined keyword in Java. Short, but which type of predefined keywords they are? Primitive data type they belong to primitive data type, but still they are the keywords only. Okay. Lot of keywords there. There are a lot of keywords in Java, guys. Okay. I go here and list down all the different keywords in Java. If you write down, okay, you will get all the list of the keywords we have in Java, guys. Okay. You see, these are the list of the keywords we have. Don't need to by heart all this stuff, guys. Naturally, we'll learn a lot of stuff here. Okay. Naturally, you guys are going to learn all the keywords of Java. So what I will do here is in the upcoming sessions, okay, I'll take a topic on different keywords we have in Java. A separate topic on different keywords we have in Java I'll take. Okay. So if I have not covered some keywords and we can experiment and all, I'll take that session. So these are the different predefined keywords we have in Java, guys. Based on the list of keywords also, we can learn Java, guys. Okay. So the moment you feel that you have learned complete Java, but when you refer this Java keywords and find out a particular keyword you have never used, maybe you can refer to the topic and gain that knowledge of Java that you have not learned so far. Okay. You can use that as a thing. Is it go to and const are reserved but not used? Potential further use. Okay. Something like this. Okay. Fine. That's okay. That's not a big deal. So let's go back to the topic. We have completed byte and short for now. The next keyword, next data type, primitive data type we have in Java after the byte and short is int, guys. As short is the double the size of byte, similarly int is the double the size of short. What is the size of the short? 2 bytes. Then what will be the size of the int? 4 bytes. 2 to the 4. Size of the int will be 2 bytes. So if it is size of the short is 2 bytes, double the size of short, that is int, is 4 bytes. If it is 4 bytes, 8 for the 32 bits. Okay, 8 into 4, that is 32 bits. The range will be 2 power 32. 2 power 32. Okay, it will come like this, guys. Okay, you can also type in chat GPT 2 power 8 for the that you see 16 to the 32, right? 4 bytes means 8 for the 32. Okay, 32 bits, 2 power 32. I need to calculate. It will come around the same number, guys. 4294967 296. Okay, it's kind of different, right? Yeah. Give me a second. Am I doing anything wrong? Yeah, -1 I have to write, right? 2 power 31. Okay. So here, as per the formula, we have to write 2 power 32 minus 1 we have to write. Okay. That's the problem. Just one number, right? The wrong value got. Okay. So you see earlier I calculated, right? Instead of 2 power 16, I calculate 2 power 15. Similarly here, instead of calculating 2 power 32, we have to calculate the actual thing that you have to calculate for integer is 2 power 31. Okay. As per the formula, you have to say -1. Okay. So now you'll get the correct answer. 2147483 648. Yes, is that correct? 2147483 6482 plus 214 483 647. Okay. Okay then. Great. 2147483 648 to 2147483 647. Okay then. So this is the range, guys. One extra number will be there here. One extra number will be reduced because of the zero that you already know. Okay, so let's try to give a bigger number here into int c is equal to 9. If I write, not a problem. Double nine, not a problem. Triple nine, not a problem. Four nines, not a problem. Five nines, not a problem. Six nines, not a problem. Seven nines, not a problem. Eight nines, not a problem. Nine nines, not a problem. 10 nines, there is a problem. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there is a problem because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. You see, the last number that you can provide is 2147483 647. Okay, that is the reason this number is way bigger. Okay, 2147 2147 483 483 2147 483 647 647 2147 483 647. Okay. 2147 483 647. Okay, these are the numbers we have. Here I'll write down system.out.println. If I write, see, this is the biggest number that we can store into the biggest positive number that we can store into the variable we declared with in data type, not more than that, guys. Okay, we cannot store more than that. Okay, you see, it's working fine. Hope you understand, right? You see, it's not possible for us to remember all these numbers and all. Maybe byte you can remember like one minus 128 to 127. At least 32767 you can remember. It becomes very difficult for you to remember. No need to buy hard, guys. If you want to remember, you can remember. Don't want to remember also is fine. Okay. Simply say that 4 bytes is the size. That's nothing but 32 bits. As per the formula you can calculate and tell them. Okay. Instead of remembering this number and telling them, you can remember this formula and try to calculate that and tell them if required. Okay. Fine. Now, then we have the next data type we have in next primitive data types apart from the byte short int is long data type. Okay, the next primitive data type we have is the long data type. As mentioned, okay, short is double the size of byte and int is a double the size of short. Long is a double the size of int, guys. Okay, long is a double the size of int. How long is the double the size of int? The size of the long is 8 bytes. That is nothing but equal to 64 bits. 64 bits. 8 bytes, 8 is 64 bits, guys. So what is the range of? You see, the number will be very big, guys. You know, it's very difficult for us to remember this much big number because 2 power minus 2 power 64 minus 1, 2 plus 2 power 64 minus 1 minus 1. Okay, that is a formula we have to implement here. This much bigger number you will get. Okay. So here I have tried 2 power 63. I need to calculate. Instead of 64, I have to calculate. And then I'll get the bigger number, 2 power 63 is nothing but 9223372036854775808. Okay. With that note, let's try to create a variable with a long data type. Long D is equal to 9. Yeah, it accepts. Double nine, it will accept. Triple nine, it will accept. Four nines, it will accept. Five nine, it will accept. Six nine, okay. Seven nines, okay. Eight nines, okay. Nine nines, okay. 10 nine, error is coming. Why? We thought like, this number is still less than this number, right? You see, this number is very big. Why it's not accepting 10-digit number? Why a variable declared with the long data type is not accepting this 10-digit number? It's very important to understand here, guys, okay? You see, whatever the data you are assigned to the variable is of the literal type. There is, data type is byte, but literal type is integer here. 127 integer type data you are storing to the variable of byte data type. Okay. A variable declared with a byte data type can accept the data. There is no byte literal kind of, okay. There is nothing like byte literal kind of stuff here. Integer literal is there. Okay. There's something known as integer literal. Okay. Here, this is an integer literal. 127 is a numerical non-decimal integer literal. Okay. You may think this is a byte literal, but it is not a byte literal. It is an integer literal. The range of the integer literal will be the range of the int data type only. Okay. So in Java, we have integer literal range. Okay. The integer literal range is this one. Okay. Integer literals. So there are different type of literals we have in Java, guys. There is a topic on literals, guys. Okay. I'll be covering about the topic of literals here. Like the variables can be declared with some data types and can be specified as particular data types, right? Similarly, the data that you are storing into the variables is also of different types of literals. So numerical data, numerical non-decimal data that you are trying to store into the variables is nothing but the integer literal. Though this is in the range of byte data type, this literal type is still integer literal only. So this literal is also integer literal only, guys. Okay. If you are trying to store like this format, right, this is called as an integer literal. The integer literal size will be 4 bytes only, but long data type size will be 8 bytes, but this is 4 bytes only. So if you, this integer literal cannot be 8 bytes. Integer literal cannot be of the size 8 bytes, guys. Okay. So there is a restriction in Java where you can store integer literals into the variable declared with byte data type if it is in byte range. We can store integer literal into the variable declared with char data type if this particular integer literal size is, okay, range is in this short data type range. You can store integer literal into the variable declared with int data type, okay, if the integer literal size is within in data type range. But this is an integer literal, but there is a restriction for the integer literal itself. Okay, though this number is not beyond what long data type can store, this is less only, right? Long data type can store a value bigger than this particular number. Still, why you are getting a number error here? The problem is not with the long data type here. Okay, the problem is with the literal type here. This on the right side of this equal symbol where we have this literal, the literal also will have a restriction. All the integer literals have a restriction of the maximum number of the integer literal is up to this one only, 2147, like this only. Till here only the last number of the integer literal will be there. The data restriction is there. If I give 8 also, error will come because this integer literal is out of range will come. Okay, whatever the literal you provided is of int type is out of range is a problem. Then how to overcome this problem? The problem here is you cannot store integer literal into the variable which is declared with the long data type because the last number of the integer literal is, I can store integer literal into the variable of long data type if it is in the integer literal range. But if I increase a number like this, I cannot store. The reason behind that is this, okay, this cannot be an integer. Integer literal is out of range. So any value out of the range, and if you, because long data type can accept the numbers from, this much bigger numbers it can accept, what you have to put at the end is capital L you have to put. For a while, just put capital L here. You have to put capital L. I'll be explaining about the literal types later. For now, you see, more than that integer literal range, without putting L, this data will be considered as integer literal. If you put L here, then only this literal will be considered as long literal. Long literal range will be like this, and it can be stored into the variable declared with long data type. Okay, that's the reason, guys. Okay, within the range, no problem. If you are trying to store only 9, not a problem. This integer literal is lesser the size of the what long data type can accept. So integer literal is within the range, and the value that can be stored into the variable is also accepted because long data type can accept this kind of value. But the moment you provide some bigger number more than this range of the integer literal type itself, okay, it will be confusing, but you need to understand clearly, guys. Okay, like variables data types have some range of values that can be accepted. Similarly, there are different type of literals also. I'll be covering about the different type of literals later. In that, one type of the literal is integer literal. I can store integer literal within the range if the size of the variable accepts, by data type size accepts. I can store the integer literal value into the short data type, the size of the short data type accept this integer literal value. Here I am not saying byte literal. This is an integer literal, this is an integer literal, this is an integer literal, but the maximum value of the integer literal is up to here only, which is same as the maximum value the variable c, which is declared with int data type can accept. Okay, the maximum value of the integer literal is this one only. The maximum value of the variable which is declared with int data type is also same. So no problem here. Okay, but here the maximum value that the variable d of lang data type will accept is more than this number. But the problem is, why this problem is coming with this literal? Because the restriction is not with the variable which is declared with the data type. Okay, the size of the data type is 8 bytes, but here the size is less than 8 bytes only for this literal, but this integer literal doesn't have that size. Okay, the last number that integer literal data can accept is this one. Okay, the error is not coming because of the data type declaration here, the error is coming because of the literal restriction. More than this number, if you give extra number, right, you have to mark that as L. Like this, you have to give L. Then it becomes a long literal. Long literal can be of this much big size. You see, if I add 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, you see, no problem at all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 also not a problem. 12 digits. 13, 14, 15, 16, 17, 18, 19. You see, till here it is okay. This much big number I can store only when this literal is mentioned with L. Then it is no more this particular literal mentioned with L is no more an integer literal. It is a long literal. Integer literal cannot go behind this. So I have to store long literal behind this. Till here I can store into the variable with a long data type, because long data type is of 8 bytes. Integer literal till the maximum number is 4 bytes. I can store 4 bytes of size into the 8 bytes. But behind this, if I want to store a number into this long data type declared variable, the literal size also should be more. Here integer literal max size is 4 bytes, but here long literal maximum size is 8 bytes. So I can store this kind of thing into the long data type variable. Okay. So size is not only applicable for the variables of because of the declaring the variable data types, guys. For literals also there are, for literal types data also, for literals also there are some types like integer literals and long literals, etc. I'll explain more about the literal types later in the upcoming sessions, guys. Okay. In the upcoming session, I'll cover more about the literal types here. So if you're trying to give a number bigger than the integer literal maximum number into the byte into the long data type declared variable, then in that case you have to put L, capital L at the end of the literal. Then it becomes a long literal, and we can go with bigger number and store into the long data types. Okay. Okay, and this long type of literal will be generally used in scientific kind of application for general development. Okay, int will be mostly used, guys. Okay, long we will not use. If you are working with scientific applications where bigger numbers will be stored, then only long data type will come into picture. But most of the projects which are built using Java programming will basically use int data type as a regular one. Okay, so long will be specially used when you deal with you are developing some application where bigger size numbers more than integer literal range is required, then only you'll go with the long. Okay. Okay, then great. So guys, I explained about the data types. In that primitive data types, I covered byte, short, int, long. Okay, numerical, non-decimal data types I covered for now. Okay, in the primitive data types, these first four data types are numerical, non-decimal, primitive data types. Okay, primitive data types. And here the other two data types we have like float and double R. Other two data types we have here are float and double R. Numerical only. These are also numerical, like byte, short, int, longer, numerical. But they are non-decimal. This byte, short, int, long are non-decimal. They'll not have any decimal value. Where float double can accept the data which is numerical data, which is in decimal format. Okay, float and double are for storing the decimal values, decimal numerical values. Okay, byte, short, int, long will accept numerical non-decimal values, where float double will accept numerical decimal values. That's the difference. Okay, 1, 2, 3, 4, 5, 6 are numerical types. Till here are 6 primitive data types are for numerical values storing only. But in that first 4 are non-decimal numerical. Second 2 are okay numerical decimal types. Okay, till here numerical, but this float and double are decimal types, numerical decimal. Whereas byte, short, int, long are non-decimal numerical. Here decimal numerical. Okay, fine. Apart from that, we have char and boolean. These are not numerical, non-numerical itself. Okay, here first six are numerical, where char boolean are non-numerical. Okay, char boolean are non-numerical. So I'll explain more about this primitive data types I have didn't complete in this session, guys. Okay, I didn't complete the complete primitive data types. I didn't complete in this particular session because the session is becoming lengthy. I'm stopping here with byte, short, int, long. In the next session, I'll cover the remaining primitive data types, that is float, double, char, and boolean in depth. Okay, to a good extent I will cover, and there are other topics regarding the data types are also there, which also I'll be covering in the next session. Okay. So I'll be dividing this primitive data types or data types topic here into two parts. First part I completed in this session. The second part of this primitive data types or data types I'll be covering in the next session. Okay. Till then, see you. Bye bye. Take care, guys.